Hello and namaste. So in this particular session, we are dealing here with the self-observation slide of the Poisson distribution under the playlist of probability distributions. We are going ahead with the two different questions which I have given you as a self-observation slide in the particular session in detail. Now, first question: in a certain factory turning out razor blades, there is a small chance 1 upon 500 for any blade to be defective. The blades are supplied in a packets of 10 using Poisson distribution. Calculate the approximate number of packets containing no defective, 1 defective, 2 defective blades respectively in the consignment of 10,000 packets. Now first of all we have to identify what are these numbers given to us with us. Okay, now if you observe the chance means the probability is given to us as p, small p as 1 upon 500. That probability occurs in the packet of 10. So the small n, the value of small n is coming out to be 10. And we have to find out the probability of all these 1, 2, 3 in the consignment of 10,000. So this 10,000 is giving you the capital N. Now, from this P, N and capital N, we can go ahead with the mean, which is a parameter for the Poisson distribution. They have given you that this is a Poisson distribution. So mean is lambda, which is also same as M, which is NP is equals to 10 into 1 upon 500. This is 1 by 50, which is 0.02. And this is known as the PMF or probability mass function for the Poisson distribution. If we put these values over here, we are going to get the values probability of x is small r is equals to e to the power minus 0.02, 0.02 to the power r upon r factorial. Now moving ahead to the first one, that is no defective. Now if we need the no defective, that means what? We should have the value of small r is coming out to be 0. That means if we put small r is equals to 0 in this particular formula everywhere in this, we are going to get it. The probability of capital X is 0, that is e to the power minus 0.02 into this, and 0.02 to the power 0 is 1, 0 factor is also 1, so we are going to get it 0.9802. Now this is the probability of the no defective in the packet of 10, but we need to have this under the consignment of 10,000 packets. This is the probability of just this 10 packets, and therefore, or a 1 packet, we need the approximate number of packets containing no defective in a consignment of 10,000 packets, means the probability into the capital N, that is 0.9802 into 10,000 is 9802 number of packets would not be having no defective in this. Similarly, this is the probability distribution function or PMF, probability mass function. I have kept it purposely again. Second case is 1 defective. Now if we are going to go with 1 defective, it has to be r is coming out to be 1. So putting these values r equals to 1 everywhere in this, we are going to get the same way. It is 0.0196. Again it is in a packet of 10. Therefore we need the consignment, entire consignment, so it has to be multiplied with the 10,000. We will get 196, which is the answer I have given you in the second case. Now the third one is 2 defective, that is r equals to 2. If you are going to go ahead with r equals to 2, means we are going to go with keeping this r equals to 2 in this particular formula or in this by PMF, we are going to get the value as 1.9604 into 10 to the power minus 4. But again in the 10,000 consignment of 10,000 packets, it would come out to be 1.9604. As we are finding out the number of packets, we need the number should be a complete number. That's the reason we are approximated to 1.9604 to 2 number of packets which will have 2 defective. I think it's I have written it 2 here, 1 here. It's 2 defective number of this one here in this case. So this is about the question number 1. Second question is, let x be the number of cars passing in a certain point per minute at a particular time. Assuming that x has a Poisson distribution with a mean 0.5, find the probability of observing 3 or fewer cars during any given time. Now let x is the number of cars passing a certain point per minute at a particular time. So mean is been given to us as this 0.5, that is lambda is equals to 0.5, that is x follows the Poisson distribution with 0.5 as a parameter. This is the PMF function, and we can write down this e to the power minus 0.5 into 0.5 to the power r upon r factorial. Now the probability of observing three or fewer cars of during any minute, that is nothing but probability of x is less than or equals to 3, that is probability of x is 0 plus probability of 1 plus probability of 2 plus 3. Putting these values here in this equation respectively 0, 1, 2, 3 values, we are going to get it here. Just by simple calculations we will be reaching to the answer.